Hey guys, so today we're going to keep practicing performing our dilations. And again, there was two types, either dilating it from the origin, from the center 0, 0, um, or dilating it from a specific point on the shape. So that's what we want to keep practicing today. We're pretty much at the end of this unit. So again, next week, just a heads up, we'll hit review mode with the study guide, and then we'll be taking our actual test for dilations. So let's go ahead and move forward here. And again, you guys will be performing the dilation, right? I will give you as a pre-image. I'll give you a scale factor. You just got to be careful. Is the dilation happening from the center or a specific point on her shape? Again, there are two types of dilations, right? If you're performing a dilation from the origin, right? From the origin, use the coordinates, use the original coordinates, and then you just multiply by your scale factor. You multiply everything in there by your scale factor. Okay. If you are performing a dilation from a given point, so imagine like P here is the center, not 0, 0, right? As the other one was the center. Imagine that again, those lengths from P to the other sides are getting pushed or pulled towards that point. So you can kind of see here that P used to be just a distance of 1. It now doubled, or sorry, it looks like it tripled in size by a scale factor of 3, right? So you take that -1, you multiply it by a scale factor of 3. Same thing down here. It used to be a distance, the length used to be -2, and when you multiply it by a 3, it turns into 1, 2, 3, 4, 5, 6. So when the dilation is happening from a specific point, you're working with the sides, not the actual coordinates. All right, be careful. We're going to practice those two one more time today. So example number 1 says dilate using 1/2 as the scale factor. So just taking a look at my scale factor, if it's 1/2, that pre-image should be shrinking, right? Should be shrinking by half its size. Now, the origin is the center of this dilation, right? So when the center is 0, 0, when the center is your origin, it's not bad. It's not bad because all you have to do is use the coordinates, right? So let's find the coordinates for A. Original A, that looks like it was 2, 4. All right. B over here is at -2, 2. And then C is down here at 4, -2. So C is down here at 4, -2. We're going to apply our scale factor of 1/2. All right. That means that you're going to go through and you're going to multiply everything in here by half. Okay. Everything, your X's and your Y's are all getting multiplied by 1/2. So I'll show the first one. I'll go ahead and show the first one. Oops, let me erase that. So here, this first one, what's 2 times 1 over 2? Well, 2 times 1 over 2. Remember how to multiply fractions. That's 2 over 1. So I multiply across my numerator, across the top. 2 times 1 is 2. Across my denominator, 1 times 2 is 2, while 2 divided by 2 is just 1. So for A prime, I know that my new X value, A prime, don't forget the prime, is going to be 1, comma. Let's do the same thing with the Y's. 4 times 1/2. We'll have 4 times 1/2. That's 4 over 1. 4 times 1 is 4. 2 times 1 is 2. 4 divided by 2 is 2. So that is the coordinates now for A prime, 1, 2. And again, when you ever multiply, guys, by something like 1/2, you're really just dividing by 2. 1/3, if you multiply by 1/3, you're really just dividing by 3. If you multiply by 1/4, you're really just dividing by 4th, and so on and so on. So I really won't show it for the others, but right here, what is -2 times 1/2? What's -2 divided by 2? That would give you, whoops, B prime. -2 divided by 2 is going to give us -1. Same thing over here. 2 divided by 2 is going to give us, in this case, though, +1. And then lastly, for C prime, same thing. 4 times 1/2, or 4 divided by 2, is 2. And similarly here, what's -2 times 1/2? -2 divided by 2 is -1. So let's go through and actually Plot those points. Let's actually go through and plot those points, right? And because this is from the center and our scale factor was 1/2, it's shrinking, and I should see everything starting getting closer. Again, think of it like a black hole. It's pulling everything towards the center of our graph here. So let me plot the first one, 1, 2. So 1 to the right, up 2. That's my new A prime. Right? Sorry, all these other little red dots are getting in my way. What about B prime? That's -1 to the left and up 1. That is B prime. And then lastly, C prime, it's 2, 1. 2 to the right, -1 down. C prime. So take a look at our new image here. A prime, B prime, and C prime. It shrunk, right? So it makes sense. If my scale factor is half, it shrunk by half its size. And notice that A prime, B prime, and C prime are getting pulled closer and closer and closer to 0. All right, so there we have it. That's an example of dilating from the origin, right? That's my personal favorite. It's not too crazy. Use the coordinates, multiply by your scale factor, and then go ahead and plot your points again. Let's try it again for example 2. It says perform a dilation from the origin. All right, so again, these are my personal favorites. So from the origin, it's not too crazy. We're here at the center, 0, 0. And we're going to be using a scale factor of 2. So it should expand my image. I should see, again, think of somebody placing TNT, some dynamite at the center of your graph, and it's going to blow everything away from that center, right? If my dilation has a scale factor of 2, it's expanding, it should expand everything away from that center, in this case 0, 0. So let's take all of our coordinates from before. A, that is 2, 0, 2 to the right, and we stay there. What about B? B is negative, excuse me, it's going to be not negative 2 yet. It's 0, we stay at 0, but we do go down -2. And then C is going to be -2 to the left and up 1, -2, 1. And then lastly, D is going to be 1 to the right and up 2. Whoa. All right, there we go. Had technical difficulties. Sorry. D is going to be 1, 2. So again, those are all the coordinates of our pre-image, right? This is the before. All we have to do now is apply our scale factor. Our scale factor was 2, right? Basically going to go through and double everything. We're multiplying all of our coordinates by 2. Everything in here is getting scaled by a factor of 2. So let's go through and see what that looks like. A prime, well, 2 times 2 is 4. 2 times the 0 there is just going to be 0. Let's move on to B prime. 2 times 0 again is just 0. 2 times -2 is -4. What about C prime? Well, 2 times -2 is -4. 2 times 1 is 2. What about D prime? 2 times 1 is 2. 2 times +2 is +4. So there we have it. These are the new coordinates of our image, A prime, B prime, C prime, and D prime. We just got to go through and actually plot those. So I'll start over here at A prime, 4 to the right, and I stay at 0, 1, 2, 3, 4. Label that your A prime. B prime is I stay at 0, but I do drop down to -1, 2, 3, 4. That is my new B prime. Don't forget the primes. C is at -4 to the left, -1, 2, 3, 4, and up 2. C prime. And then lastly, D prime, 2 to the right and 4 up. That is D prime. Okay, go ahead and connect your new image. Connect your new image. Whoops. All right, there we go. There we go. And then lastly, down there. Right, and we can see that our image, right, our new image pretty much doubled in size. And again, it's getting pushed away from that center, right? It's getting pushed away from our origin, 0, 0. All right, so there we have it. Those are 2 examples, guys, when you're dilating from the origin. All right, what if we're not dilating from the origin, right? Take a look at example 3 and example number 4. It says dilate the square using a scale factor of 1/3. So I should be shrinking it, right? I know I should be shrinking. My scale factor is 1/3. It's between 0 and 1. So it should be getting smaller. It should be getting smaller towards A, because A is going to be the center right here. So A is my center. A is also going to turn into A prime. But because my scale factor is 1/3, it's going to be shrinking everything. B, C, and D, think of those as shrinking towards A. They're all getting pulled towards A. So this time we actually don't get a chance to work with the coordinates. We have to work with the lengths, the actual lengths. So from A to B, this used to be 1, 2, 3, 4, 5, 6 units. Okay. Now we're actually going to apply our scale factor of 1/3. If I apply that scale factor of 1/3, well, that's 6 over 1. 6 times 1 is 6. 1 times 3 is 3. 6 divided by 3 is 2. That distance right there that used to be 6 is now going to be cut all the way down to 2 units, just 2. That is going to be my new B prime. Let's try that same thing with the distance from A to D. From A to D, it's 1, 2, 3, 4, 5, 6. Also used to be 6, right? If we apply that scale factor again, 6 times 1/3, well, it's going to give us the same thing, right? 6 times 1/3, it's still going to be 2. So that distance is also shrinking. Before it used to be all the way over to 6, it's now going to shrink just to 2 spaces. That is going to be your new D prime. And you can kind of ignore the third corner over there, C, because we can kind of already see, hey, if this was a square, right? Hopefully we get the idea here. A is still going to be A prime. That's D prime. That's B prime. Guess where C prime is going to be? Right there, because it's a perfect square. That's where C prime should be, right? That distance of 6 would also be shrunk down by 1/3, right? So there we see our new image, right? Our new image is in blue, right? And again, notice how everything got pulled towards A. A did not move at all. That was like your anchor point. Imagine you put a pin on there, right? A little safety pin, and then you're reeling everything in towards A. All right, let's try that one more time for example form. It says, perform a dilation using a scale factor of 3 and point A as your center. So again, this time, A is my center, so I can't use the coordinates. Things are going to either move towards or away from A. Well, because your scale factor is 3, that means it's going to expand. So these distances are going to stretch out, right? They're going to expand away from A, but A is still going to be in the same spot. A will still turn into A prime, right? A slash A prime, if you want to think of it that way. It's the exact same coordinate. So let's take a look at the distance that used to be from A to B. We'll start here. A to B used to be a distance of 2. So let's take that distance and apply our scale factor. A scale factor of 3, multiply it by 3. 2 times 3 is going to get us 6. So 2 times 3 is going to get us 6. So now instead of just going down 2, I go 2, 3, 4, 5, 6. That is where we're going to place our new B prime. All right. So this would be our new right side of this image. Take a look, right? It's expanding, it's away, moving further and further away from A. All right, let's take a look at the top side. The top side used to be 1, 2, 3 units. So what's 3 times my scale factor of 3 again? That's going to give me 9. So instead of just being 3 units away, right? D used to be 3 units away. It's now going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 units away. That's going to be the new D prime. All right. I'll actually go ahead and connect those right now so you can kind of start to see our new image. Okay. The last one we're going to do here is we're going to talk about the distance from, talk about the distance from B to C. So from B to C, take a look. That used to be 1, 2, 3, 4 units. So the bottom of the shape used to be 4 units, but when we apply our scale factor, when we multiply it by 3, we get 12. So now that bottom distance, right, we don't count from B, we count from B prime down here. We're going to count down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so we're going to put it there at 12. Whoops. That is the new distance from B prime to C prime. B to C used to be 4. Now our scale factor was 3, so it's now a distance from B prime to C prime. It's now going to be 12. And then, of course, at the end here, guys, you just go ahead and connect your diagonal. But there we have it. There we have it. Take a look how A and A prime, it never moved, right? It was just pulling everything away from that anchor point from point A.